Hi everyone. What we're going to be doing in the next few minutes is a really quick playback recording of how to use a private DNS and hence a private container registry with IBM Kubernetes, and also how you can apply this to IBM CFI as well. Before we show the live demo, wanted to go through a picture just to demonstrate what the problem is, help you better understand it. Basically, what we're trying to do is take IBM IKS on VPC, combine it with a private container registry, combine it with a private DNS, and I guess in a way, lead to a level of happiness here. So the requirement is to use an on-prem container registry. Now, this on-prem container registry is something that only the private DNS server knows about. So this could be something like private registry.gcat.cloud. Here's the challenge, though, is that when you deploy an IKS cluster, these worker nodes are configured with the IBM Cloud DNS server, which knows how to resolve, public internet host names. It knows how to resolve its own IBM Cloud Container Registry, but it has no idea about this private container registry that is running within the enterprise. Now, to actually configure it, when a worker node needs to pull an image from the container registry, it's actually going to use the DNS server that's configured within the worker node OS itself. So we need to somehow get into the worker node operating system and update the DNS configuration. If we don't do that, we'll get a hostname not found error message. Different ways of doing this, but at the end of the day, when we make these configuration changes, we want to do it in a supported way, and we also want to make sure that the changes will survive any worker node reloads. So maybe the Kubernetes cluster is scaling and you're adding new worker nodes, maybe a worker node has to be reloaded. Whatever the case may be, you don't want to lose those DNS configuration changes that you've made. So how do we do this if we technically cannot get into the worker node? So technically, you can't just SSH into a worker node and make changes. That's a no-no. The answer is to use a Kubernetes daemon set, and it's actually quite easy once you figure out how to do it. But as the saying is going, the devil's in the details. So let's take a look at how we could use a Kubernetes daemon set, do some worker node reconfiguration, have it point to our private DNS server, and as a result, when it needs to load images from the private container registry, it knows how to get to it. So let's switch to the demo here. So before I begin, just wanted to point out this is the Kubernetes cluster that I will be using. I noticed there is no public endpoint. It's completely private, has basically 3 worker nodes deployed into a multi-zone Dallas region. But since we like to work on the command line, let's stick on the command line and demonstrate what we're doing from here. Okay, the first thing we want to do is do a deployment. So let's do kubectl apply -f DNS test deployment. And that's created, and just to take a quick look at this deployment YAML file, nothing too fancy here, just a basic YAML file, but the important thing is notice my image is coming from my private registry. Now if I do kubectl get pods, see it's actually having a problem getting the image. So if we wanted to take a closer look at what's going on with this, let's do kubectl describe pod. And you can see right away it's having a problem. The worker node does not know how to resolve that hostname because, again, it's on my private DNS server. So how do we get these worker nodes to point to our private DNS server? Let's go ahead and remove this deployment. We'll fix the problem and retry it again here in a bit. Well, that's to use what we refer to as a daemon set. And let's take a closer look at this daemon set. Now, it's nothing too ordinary here, but the key is, as they say, the devil's in the details. Is you'll see this daemon set actually runs some commands. And let me zoom out here so it wraps a little bit better. Here, let's do this so the wrapping is a little bit nicer. There we go. So you can see that the only thing we need to update is our private DNS IPs. So I only have one, so I'll stick that here. But you can see that it's using some nsenter commands to go in and make some changes. Now, the worker nodes are running Ubuntu, I believe it's 18, but the good old days of just going in and modifying the resolve.conf file, that's not in this current version. It's actually using the new way. So you actually have to go in and update a YAML file, run a netplan update, and that is actually how the DNS on the worker node gets updated. So it's not as simple as updating that simple CFG file. Anyhow, you can look through these commands in detail. Let's go ahead and apply this. And it's going to go ahead and get running. So let's look at the kubectl get pods again. Now here's our daemon sets. For those of you that aren't familiar with it, that basically ensures that this pod runs on every worker node. It's automatically handled for me by Kubernetes. The other nice thing is that if I do a kubectl logs on this pod, you can see that that script, remember it was outputting some messages. The script actually is outputting, and I can actually see the logs and what's working. So you can see that it's actually running it. It made a backup copy of the original file. This is what the new file looks like. It runs a netplan apply to update the DNS changes, and it does a verification. Here's what the updated DNS configuration is for the worker node. And you can see the worker node is now using my private DNS. So it looks good. And by the way, because it's a daemon set, if I need to reload this worker node, add a new worker node to the cluster, it automatically makes these changes for me. So let's try applying our deployment one more time. So that's created. So let's go ahead and take a look at our pods. And there you go. It's pretty quick. It was actually able to already pull the image, and they're in a running state. And if we just want to take a quick look at those logs, actually, let's do this. Describe pod, that's what we were looking at before. You can see here that it actually was able to successfully pull that image, right? So what did we do? We basically just went in, used the daemon set to update the DNS configuration of the worker node at the operating system level so that it knows how to pull and resolve our images from our private registry, knows how to use our private DNS server. The work is not yet complete though. Let's shift gears and take a look at the second part of this playback video. So in the first part of the video, we were able to successfully configure the worker node DNS server so that we can pull an image from our private container registry. Now let's take a look at what happens to an application that's running within the IKS cluster itself. I was able to deploy a small node app that you basically can pass a service name or host name, and it will resolve that name that's passed. You can see the IBM.com gets resolved, no big deal. Let's take a look at when we try to resolve something from our private DNS server. Well, that didn't work. So what ends up happening is if we want our applications to be able to resolve host names from our private DNS, there's still some work that has to be done. And one of the reasons for that, or the reason for that, is our Kubernetes cluster uses core DNS for name resolution. Previous versions of Kubernetes use kubedns, so don't get confused if you see kubedns, but the more recent ones are using core DNS now. Net, we need to configure core DNS to leverage our private DNS server. Now, what I'm going to be doing is something that's actually part of the documentation. So there's this whole section on configuring core DNS for VPC clusters within the Kubernetes documentation. And you can see here that this is a supported and recommended way of doing this. So let's see how this works. I'm just going to run that command. And it's kind of a VI type environment. So let's go ahead and insert some lines in here. And I will do import IBM GCAT core file. And we'll just add this core file to the end of this section down here. Let's call it IBM GCAT core file. Follow a similar structure. And what we're going to be doing is, let's do this for IBM GCAT. I have to make sure we type it correctly, IBM GCAT.cloud. So for that domain, I'm going to do some specific things here. Now, let's just type in errors. Let's just type in cache this for 30. And instead of proxy, let's just do the more, the newer way, forward to 10.240.0.11. Now, you could look into the core DNS documentation, and there's tons of other plugins you can use. I'm just going to stick with this for now, just to demonstrate how this works. But you can see here that I'm going to forward anything for the IBM GCAT.cloud domain to my private DNS server. And note that this also has a reload plugin as well. So what this means is I can go ahead and save this configuration. And let's clear the screen so we get a nice clear screen again. And because that reload was there, let's just wait a minute and it'll automatically reload the configuration. If that wasn't there, we would have to just restart the pod to pick up the changes. But let me pause for a few seconds. I'll be right back, and then we'll run the test again. Okay, so let's try this again. You can see here that the app resolving the public one still works perfectly fine. But now let's go back and try my host name for my private DNS again from the IBM GCAT.cloud domain. And there we go. Now it's able to resolve it. So my Node app on my Kubernetes cluster is able to resolve names that are coming from my private DNS. So the last part of this playback is we've talked about the Kubernetes worker node, an app running within Kubernetes. Let's wrap things up and talk about an application that's deployed within CFI as well. Okay, so what we're going to be doing in this last part is taking a look at a CFI environment. It's already been configured just to save some time, but just to demonstrate what was done to get this to work. So it's the same Node application just running again on CFI. You can see here that if I call the application and I pass in the IBM.com host name, it resolves perfectly fine. If I pass in my private host name, that's resolving as well. Now, CFI is running on top of an IKS cluster, so you can get a listing of your clusters within your environment, and as you would expect, you can just basically edit that same config map for core DNS for your cluster. Now here's the config map for the Kubernetes cluster that CFI is running on top of. And because CFI is running on top of this Kubernetes cluster, as you would expect, there's a little bit more configuration here. But the pieces that I added, again was this import for my core file. So there's my import IBM GCAT. If I scroll on down, you could see that CFI has its own things in here as well. But I went ahead and added in my IBM GCAT core file section in here. And that was really about it. So just added in this section, just like you saw in the past, did a save and close, and at that point it was working perfectly fine. So that's the end of this playback. We started off by taking a look at how to modify the worker nodes for Kubernetes to be able to pull images from a private container using a private DNS. That was, required us to use a daemon set to modify the operating system DNS settings. And then we took a look at an application running inside of Kubernetes and modifying the core DNS files. Lastly, after learning how to do it with Kubernetes, we just applied the same knowledge to a Kubernetes environment for CFI. And we could see here we were able to apply what we learned to the CFI environment as well. So that's it. I'll end the video. If you have any questions, please don't hesitate to reach out to me. Thanks a lot. Talk to you later. Bye.